When electromagnetic radiation interacts with biological tissue, it is either absorbed, transmitted, reflected, or scattered. The type of tissue and the wavelength of the incident radiation determines the extent of these processes.
What happens to a tissue that absorbs radiation?
Absorption of radiation can produce various biological effects. We distinguish between photochemical, thermal, and nonlinear interactions. Photochemical reactions dominate for low irradiances and shorter wavelengths. The process of vision or a sunburn of the skin are typical examples. For higher irradiances, thermal reactions dominate over photochemical reactions.
Due to the energy contained in the absorbed radiation, the temperature of the tissue rises. If the rise in temperature exceeds certain limits, the tissue can be damaged irreversibly.
Extremely high irradiances, which can only be achieved with extremely short laser pulses, induce explosive-like reactions, so-called nonlinear reactions. Tissue is only damaged if the irradiance exceeds a certain threshold. This threshold is also called the maximum permissible exposure, or MPE. The MPE depends on the wavelength and the exposure duration. MPEs for the eye and skin are the same in some parts of the spectrum, but different in others.
The MPE may be exceeded within a certain region from the laser aperture. This region is called the nominal hazard zone.
Different wavelengths or light from different parts of the spectrum are absorbed in different parts of the eye. The cornea absorbs most ultraviolet wavelengths and also longer wavelength infrared radiation. Intense irradiation beyond the MPE limit causes irritation or clouding of the cornea. The lens absorbs near ultraviolet light. Irradiation exceeding the MPE limit may cause an opacity of the lens. Visible light, that is wavelengths from 400 to 700 nanometers, is focused onto the retina where it can cause damage. Infrared light from 700 to 1400 nanometers is invisible, yet is also transmitted to the retina where it can cause damage.
Laser beams at wavelengths between 400 and 1400 nanometers are particularly hazardous to the human eye. The combined effect of the cornea and lens can focus a laser beam to a very small spot in the retina. The irradiance may be up to 100,000 times higher on the retina than on the cornea.
The retina can be damaged irreversibly.
The effect of the damage on subsequent vision in the eye is worse if the macula is affected, since this is the part of the retina where most photoreceptors are concentrated.
The skin also absorbs laser radiation. The depth of absorption varies with laser wavelength.
Far ultraviolet wavelengths are absorbed at the surface of the skin, as are far infrared wavelengths. Near ultraviolet radiation penetrates a little further into the skin. Visible light and near infrared light penetrates most deeply into the skin.
For most wavelengths, irradiances required for the skin to be damaged considerably exceed the respective values for the eye. Excessive irradiation causes erythema and long-term damage to the skin.
The extent to which tissue is damaged depends on the characteristics of the incident laser radiation. Wavelength, pulse duration, and irradiance are the main parameters.